Hello, ma'am. Good evening. Hi, everyone. Welcome to the day two session.
Good evening, sir.
Yes, ma'am. So we can start the session slowly, ma'am. Please.
Yes, please. Yeah, my screen is visible, sir.
Yes, it's visible.
Okay. So tomorrow, means yesterday we are discussing about means how to handle Excel file or the CSV file in RStudio. So we are already done this code to access the CSV file, and as well as we can check means is there is any null values in the data set, how to extract any one column from the data set. Also we have to find out the mean, median, standard deviation and variance of the particular column. Okay, so we already done this. Okay, now in the today's session we I want to discuss about if our data set is not ready to use for the data mining, then how we can prepare our data to be ready for the data mining. So there are various techniques that are available for making the data use for the data mining. So first of all, the first thing I want to discuss is about the how to handle the missing values in the data set. So if there is any missing value in the data set, then we can means either drop that value or either we can replace that value. But the problem is that if the data set size is very small, then if we drop the null values, then again the data size is more small. So in the analysis we know that if the size of the data is large, then the result of the analysis are good. So in that case we have to more focus on to replace the values in place of the drop the values. So we learn in today's session both that how to drop the null values and how to replace the null values. Okay, so first we understand this concept with the help of the vectors in R. So vector is also a one data structure in R to store the different data values. So first of all, I take one example. Okay, everyone, if you have any doubt, then please put in chat box in coding, and I also paste the code in the chat box so that you can able to do the code. Okay, so basically there are two types of null values in a data set. One is called the NA. Okay, NA means blank values, and second is called as the NaN values. That values are basically the end line statement in any files. Okay, so if there is any n value and I have to find out there is a na values or not, we already done it's yesterday. That is dot na is a method to check that is there is any null values in data set or not, and it gives you an output in the form of a binary value, that is true, false. For example, here I create a one vector. To create any vector in R, we required a one method that is called as constant method, that is C. Okay, and in that vector we can place different values. We can place number, we can place string, we can place float values, etc. Now, in this vector, you can see that there are four null values. This NA is considered as a null values. Okay, and these are the two values that are not null. So if I have to check that in which positions there are null values in the data set, so I run this code. can see the result that in first position there is a null, so it gives me a output true. In second position there is not null, so it gives output false. In third position also there is not null, so it gives false. And in the rest position you see that there are null values, so it gives the output true. So we can find out that in which positions there are null values and in which position there are not null values. Okay, so this is in this way we can check that there is any null values in a data set or not. I first do this with a vector, and after that I do this with the Excel file. Okay, so the next is how to find a NaN or end of line values in a data set. So this end of line is represented by this symbol, that is 0/0. These values are considered as a NaN value. These are very rare values, not more available in the data set, but might be possible that due to some noise in the data set, due to some error in entering the data, these type of problems may occur. So these are considered as a NaN value. So how to find that there is a NaN values in the data set or not? There is a method NaN, is.NaN. Similarly, like Na, this is a method NaN. And here I pass my vector. It gives again the output in the form of the true and false. Now, if I run these 2 lines of code, you can see that in the last 2 positions, there are NaN values. Okay, so it gives me the true in these 2 cases. Okay, rest all the cases, it gives me a value false. So NaN only understand this null NaN values, not Na values. Okay, so these 2 types of errors might be possible in the data set. So we can check that is there is any missing values in the data set or not. Okay, now how to remove that missing values from the data set? So for consider, I take one vector. This is my vector. In this vector, you see that there are 4 values and 2 null values. Okay. Now, first of all, I check that in which positions there are null values. So I use the method is.Na and I pass my vector. Now I store, you can use also this equal sign in place of this. Okay, this is easy to use. Okay, now I store that value in a new variable D. Now in D what is stored? D is stored all the positions value where there is a null in the data set. So it is stored which position? It is stored this and this value. Okay. Now I want to display the values where there is a not null. So I use this symbol. This symbol is used for not. So this is not D. Not D means the values where you get the false result, it prints only that values. Now, if I run this 3 line of code, you can see that I get only 1, 2, 3, 4. But in my vector, there is a 2 null also. So in this way, I can remove these values, null values from the data set. Okay. Okay. Everyone is with me? Can you please do this code by your own? Okay. Can I start the next program? There means the only way to remember these methods name is to do practice, nothing else. If you do 4-5 programs that are related to handling the null values, you easily remember. Okay, so there is not any means magic to remember these codes. So you just have to practice, and after practice, you easily remember the codes. Okay. Okay. So this is the first of all, I handle here the vector. Now, what if I have a data frame? So what is data frame first of all? So data frame is basically one I can say is a matrix where there is a row and columns. Okay. So the combination of row and column data structure, that is a, we can also say that it's a table type structure, and that table type structure is called as data frame. So here I first create a one data frame. In data frame, you can create according to your choice number of columns and number of rows. Okay. So now in this program, I create a first one data frame. So for creating the data frame, this is a one method, that is data.frame. Okay. Now I store that data frame in a vector, in a variable. That variable name is df. Okay. Now I want to create a data frame having 2 columns and 8 rows. Understand? I want to create a data frame having 2 columns and 8 rows. Okay. So for that, here I take a first column and I make the column name as C1. I put in column 1 values 1 to 8. Means 1, 2, 3, 4, 5, 6, 7, 8. In column 1. Now, in column 2, I put the values, some character values like B, A, C, B, anything. Okay. Now, if I here print my data set, you can see how it looks like. You can see this is my data frame where there is a 2 column C1 and C2 that I define here. And in column 1, you get value 1, 2, 3, 4, 5, 6, 7, 8, 7. And in column 2, you get values that define I here, that B, A, B, C, A, C, B. You can put any values, either string, either decimal, either number. Okay. So in this way, I create a one data frame. Now, the next is I want to add some null values in a data frame. So I know that to index any cell values in data frame, there are 2 things. That is, first is number of rows and second is number of columns. So I have to index everything or make any changes in the data frame with the help of both row and columns. Okay. So for example, I want that in my data frame df, I want to put NA means null at 4th row and 1st column. This is 4th row. This is 1st column. Okay. Similarly, I also want to put the NA in 6th row and 2nd column. Okay. So in two places of the data frame, I want to put the NA. Now, if I again print the data frame, how it looks like, you can see. Okay. You can see this is my fourth row, first column, you get NA. This is my sixth row, second column, you get NA. Okay. So in this way, you can put NA or means place NA in a particular data frame. Okay. Now, I self-made my data set dirty, means I self put means NAs in my data set. Now, what next? I have to remove that NAs from my data set. Okay. So how I can means remove? So there is a one method that is called that is called NA.exclude. Okay, that is called NA.exclude. So what NA.exclude do? It remove the column or exclude the column row that have any null values. Okay, so in our data set there are two positions, means there is a fourth row and there is a sixth row. Both row have the null data. So what NA.exclude do? It basically exclude the fourth row and the sixth row from my data frame. Now, if I run this code, you can see that there is no fourth row. You can see 3 after 3, you get 5. Okay. And there is no sixth. After 5, you get 7. So in this way, you can drop the NA values from the data set. So this NA.exclude is used to drop the null row from the data set. But it exclude both, means all row. Means not a cell value. It exclude whole row. Understand? Everyone done this? Hello? Am I audible?
Yes, ma'am. Yes, you are audible.
Yes. Okay. So in this way, we can handle the data frames. So in first program, we handle the vector. In second program, we handle the data frame. So vector is a one-dimensional data and this is a two-dimensional data. Now, I will handle a one CSV file and check how to exclude the null values from the CSV file. Okay. So first of all, I required a one CSV file. So I make my own CSV file for save. Okay. So I start my Excel and create my one own CSV file. Okay. So you can also understand how to create a CSV file. So please open your Excel. Okay, this is my Excel. Now, I created two columns. So my first column name is, for example, height, and second column name is, for example, weight. Okay, and I put some random data in that columns. Okay, and also make some rows blank. Blank means missing values. Okay, so I make here the two cells blank. Okay, now in weight, okay, yes, we can do this without deleting. That I cover in my next program. Okay, so I can replace that values by either mean or by median or by mode of the data set. Okay, so I create a one data set. You can see here that row number 2 having the null values, row number 4 having the null values, row number 6 having the null values, and row number 7 having the null value. At least one null value. Okay, so now I save this file. For example, I save in my desktop and gives the name of the file example 1, and I save this as a CSV. So I select here the CSV, comma delimiter. Okay. Now I save this. Now we already discussed means how to access any CSV file in RStudio. So I take a one variable data and I write read dot CSV, and I have to pass here the full path of the file. So my file is in the desktop. So this is my file. So I right click here. I already told you yesterday. Go to the properties, copy the path. Again, go to the RStudio. Here I copy my path and change these slashes. Then write the name of the file. So my file name is example1. Okay. So I write here example1.csv. Okay. Now, if I write here data, it gives me a data available in the my CSV file. So you can see this. Now, if you see that the places in the Excel file, CSV file, where I drop blanks, they considered it as a null values, NA. I don't put NA. I only left blank, but it considered as NA. Understand? Now, if I want to exclude the NAs, so I have to write NA dot exclude, and I have to pass my data. Okay. Now, if I run this NA dot exclude, you can see that row number, every row having the null. This row number 2 is not available. Row number 4 not available. Row number 6 and 7 not available. Why? Because in these rows there is at least one null value. So it excludes the null values from the data set. Understand, everyone? Okay, completed this? Okay. Now, the question is that I already told you that in my original data, if you can see that there are total 8 rows. But due to some errors in data entering and due to the null values, it reduced my data from 8 rows to 4 rows. Means 50% data reduction in data cleaning. So is it okay for me? So if the data size is very, very large, means you have lakh number of rows in your data set, then these 4-5 line drop is not very big problem. But if your data set size is small, then this is a big problem. We cannot drop the number of rows using the exclude method. So what we can do in that case, if this is the case, then we can replace the values, NA values, either using mean or using median or using mode. So how to do that? So in this program, you can see that I do the same. Okay, for example, okay. So in this program, you can see that this is, I create a first one data. Okay. In my data frame, you can see that there are 3 columns, marks 1, marks 2, marks 3. And in every column, there are 5 values. 1, 2, 3, 4, 5. Here also 1, 2, 3, 4, 5. So again the question is, can in one column there is a 5 rows and in one column there is a 6 rows? So sorry, data frame not means allows you to create the inconsistent number of rows in a different columns. So it is compulsory that in every column you have the same number of rows. Okay, first of all. Now you can see here that in column 1 there is a 2 null values. In column 2 there is a 1 null value, and in column 3 there is a 1 null value. Okay. Now if I print here my data, you can see that how my data look like. So one problem in the R Studio is that if you use the same variable multiple times, then the problem is that in some cases that overwriting of data is not done. So in that case, you have to go to the history and delete all your history, previous history, so that the overwriting of in overwriting the data is not a problem to you. Okay. 1 minute. So I create my data frame. Okay. And in my data frame, for example, the column 1 name is marks 1 equal to, I write, create a vector, I put three values, and one is NA, and fourth is, for example, this. Okay, comma, I create my second column equal to C, and there is a NA, for example, there is a okay. Now there is a third column. Okay. So this is okay. Now if I print my new data, you can see this data frame is created. Okay. Marks 1, marks 2, and marks 3. Okay. Now I have to replace this first column NA value with mean of the first column, second column NA value with mean of the second column, third column NA value with the mean of the third column. Okay. So I have to do this. So I have to first check that in which position there is a null value in the data or in the column. Now, you also know that if there is any null values, we cannot find out the mean. We cannot able to find out the mean. So how we can do? If we exclude the NA and find out the mean, and after that replace that mean with the NA, we can able to do this. Okay, so my data is in the new data, so I write new data. Now I have to replace the first column, that name is marks 1, so I write here $marks1. Okay, now I have to check where there is a null values in my data. So I write here is.na, and which column? This marks 1 column. Okay, so I write here new data marks 1. Okay, now I have to find out the mean of 23, 34, and only 23 to replace this NA. So for that, I use this mean method. I already told you the mean method yesterday. And I find the column of mean of column new data $marks1. Okay. I also write here NA.rm equal to true, T. So what this NA.rm can do, it exclude the value of the column where there is a null value in the column. Okay, so in the column, this is the one null values. It exclude this null and calculate the mean of this, and this. Okay, now I assign this mean in which position? Where there is a null is .na in the data set. I assign this one. Okay, now if I print this, you can see that you can see that in my original data, column 1, in third position there is a NA. Now I can replace this NA with the mean. This is 26.66667. Okay. Now, if I want to, again, there is a null in column 2 and column 3. If I want to do this, then I have to just pass the name of the column. Okay. So the second column name is marks 2. Okay. So I have to just replace the column name. Now, if I do this, you can see that this value is also replaced in second column. There is a null and it replaced by the mean. Now, same thing we can do for the third column. But you have to do this column wise, okay, not row wise. Because every column has different type of values. So you cannot replace any cell values. You have to replace the null values column wise. Okay. Now you can see that this is also replaced. So in my new data, you can see that there is no null value. I replace, there is no column row reduction. In original data, I have 4 rows. After replace, either I also have the 4 rows. But all NA values are replaced by the mean. Understand, everyone? One minute. Everything is not visible. That's why is visible now. Done, everyone? It's not a problem if only code area is visible. Because I means reduce the size. So if you want to see the outputs, and you can see the output here. Okay. Done, everyone? Can I start the next using the CSV file? Okay. So, we already do this code to exclude the null, okay, from my CSV file. Now, what can I do if I don't want to exclude the NA and I want to replace the NA? Okay, so I delete this. Now, what can I do this? So, I have to just use my columns to replace that values. So I write here, okay. So first of all, what is my variable? That is a data. And if you put dollar, you can get basically a different columns name. So first of all, I have to run this to override the data values. So there is a problem with the data because I use data multiple times. So I get my two columns. The first column is height. Okay. So I also write here data dollar, my column name. Then I also write here similarly, I have to do this with the my second column. That name is weight. Okay. Now if I print data, you can see that I get all my 8 rows. No row is excluded. Okay. And there is no null values in my data. So in this way, we can replace the null values from the data set. Understand? So either your data is the CSV file, either your data is in the form of the data frame, you can do this. Okay, everyone? Okay. Okay, now what can I repeat again? So I have to just want to replace the null values from the mean with the mean. Okay, so this is my CSV file we already created. In this my CSV file, there are two columns. One column name is height and second column name is weight. Okay, so I have to. So this is a data pre-processing. Okay, we cannot do the data mining before means after data pre-processing. We have to first do the data pre-processing, because in the real life we know that there are lots of the data available that are not ready to use. So we have to first make it ready to use and then use it for data mining. I cover one algorithm, that is a decision tree today only, and rest of all covered in tomorrow session. And yesterday I just cover only the how to handle the data, how to read the CSV files, only that. Okay. So now I take one real life data and want to do this. Okay, so I already told you that how to download the data from the internet. That is a secondary data source. So I download one data set and I share you. Okay. So I open kaggle.com. And I write here, for example, one data set is there, that is a CC general data set. For example, this is a file that is a chip data set. I download this file. I share to you. So please everyone download this file. Yes, we can scrap data. We can scrap data using us. So I make this file to be placed in my desktop. Okay. Now I want to access my file. So I put my data in the desktop. So my path is same, but my file name is chip data. That is a chip underscore data set. So I write here chip underscore data set. Okay. And I take another variable that is a chip underscore data set, data. Okay. Now if I print, so I get this my whole data set. Okay. You can see there are various null values in this data set. Various null values. Because this is a real life data set. Okay. Now, if the data size is very large, we cannot just scroll to see where there is a null values or not. So I can I write here print, then sum. I already told this to yesterday, is dot na, and I pass my data set. So it counts how many null values in my data set. Now, if I run this code, so you get this 0. The problem is that there is a 2 columns that are created but not having any values. For example, this one. Okay, there are null values. But every column, they get the null value. Every row, they get the null values. Now, if I do this column wise, now if I write here data dollar, over 1 minute, this is not data, this is shift underscore data. Okay. You can see there are 12,833 null values. Okay. So these are the very large numbers. Oh, we cannot exclude the null. So we have to check column wise and do the data clean column wise. Now these are the total number of null values in my file. Now if I want to check column wise, so I write I just pass here dollar and the name of the column. For example, I take a first column, that is a product. In product, you can find there are 0 null values. Now, if I change the column, dollar, for example, in these 2-3 columns, there are mostly null values. So I take this and run this code. You can see in this column, you get 4,318 null values. Okay. And we also don't know what is the type of this column, means which type of values in this column are. Okay. So for that, you can write print type and shift underscore data dollar any column. For example, is a release date. So it gives you the type of data in this particular column. One minute. Okay, so you can see that this type column has the data type character. So in this column, there are all the values having the character data type. Now, if I pass the other column, for example, release date, so I get is also character because there are slashes are there in the date or the dashes are there in the date. So it considered it as a character or it's considered it as a string. Okay. So we can find out the type of the values using this type of method. So we can easy to understand means how we can replace that value. Because if the values is in the form of the character, then how we can replace that value with the mean? Because the character values doesn't have the mean. Okay, in that case you cannot change or replace the character value with the mean, because the mean is not possible for character value. Mean is only possible if your column have the integer values or the basically decimal values. Otherwise you cannot calculate the means. Okay, so now what we can do to sample the data set. So in the data mining, basically when we are applying the classification or any classification algorithm, we have to divide the data into two parts. One part is called as the training data and second part is called as the testing data. Basically, training data is used to build the any classifier model, and the testing data is used to check that how the model performs, means what is the accuracy of the model. So to build any model or to find the accuracy of the model, we have to divide the data into two parts. So there is a one method that is called as sample. Sample method is used for random sampling. Okay. So for example, if I write here S equal to sample, okay, and I pass here, for example, I want 100 data from the, for example, 500 data. So this is my total size of the data, and I want only 100 data out of 500 data. Now, if I write here, for example, training data equal to chip underscore data, and I write here comma S. Okay, I explain you. Next, I write here testing underscore data equal to chip underscore data, and I write here comma minus S. Okay, so what this comma indicate? It indicates all rows and it indicates columns. So I have to write, divide the data in the form of the rows, not by the column. So I write here S column, comma, okay, and I write here minus S comma. Now, if I print here my training data, so first of all, I check so I have to pass here 500 out of 100. Okay. Now, if I run this, okay. Now, I I take 100 rows in a training, and rest of all means minus S in the testing. So if I run this code, that is a training data, you can see that in this training data, there is a just 100 rows. Okay. But the sample is of different row numbers. You can see this is not in the sequence. This is a 348 number of rows. This is a 287 number of rows. This is a 221 number of rows. Means it is doing a random sampling and fetch only the 100 rows from the data set. And the rest of the data, that is a minus S, in the another part. So in this way, we can divide the data randomly into two parts. One is a training and one is a testing. Okay. Now, if we do random sampling in every of our program, the problem is that I get the different output and you get the different output. If you run this code, means your output may be different from myself. Means you don't get the 348 number of rows as your first row. Everyone, please do this and check that you get the same number of row or different number of row. Mostly get the different number of rows because this is random. Everyone do this. Please tell me what results you get. Different? Yes. So what I can do if I want that everyone get the same? We have to do random sampling, but I want that my and your both results are the same. So we can use one method that is called seed. So I use set.seed is a method. So if the seed of you and mine both are same, then we both get the same results. Okay. For example, if I put my seed here 100. Okay. And I run this code again. Okay. Now I get the 202 number of row. Please check everyone, you also get 202 number of row or not for the same data set. Please check, you get the same result or not. Hello. Not same? You don't get 202? Okay. So what row number you get after putting the seed 100? You have to run this whole code again to fix the seed. Hello. Same? Okay. Seed is nothing. For example, if I told you that if the quality of seed for any crop is same, then we get the same number of or same amount of crop. Similarly, if the seed is same for you all, then you get the same number of rows. It is random, but same. Okay. And this is used in somewhere, for example, when you are encrypting your passwords, then you know that the password is encrypted on the basis of the some seed. If you encrypt your password randomly, then what problem you get? First time you encrypt the password, you get the output. Second type, you encrypt the password, you get the different output. But you want the output same because you have to match the passwords. In that case, you require a seed. It is random, but it gives you the same number of rows. Okay? And if you set this, you get every time the same number of rows. And if you don't put the seed, then every time you run the code, you get a different number of rows. For example, if I put the another seed, for example, I put here, for example, 10. Now, can my row number is same? I check. So my row number is 491. Okay. Now I again put this 100 and run the code. This is again 202. Understand? If your seed is same, you get the same result. Random, but same. Okay. This is just only to get the same result. Nothing else. Otherwise, I get the another result and you get the another result. Then you get just got confused that how I get this result. Okay. Understand everyone? Okay. Now, if we divide the data into two parts, then I can use the training data set to build any model and testing data set to check that how my model work or no. There is a question that does it gives the same result every time. So it gives the same result every time. I cannot say this is every time true because in the random number also there is some limitation. Okay, so it might be possible you get the different result. Might be possible, but mostly in mostly cases you get the same result. Because there is some limitation of the random number. Okay, so the question is that when we divide the data into two parts, the problem is that what proportion I can take to make training and testing data. What proportion? So mostly researchers are taking 70% of your data as a training data and 30% of your data as a testing data. So for example, if there are 100 rows in my data set, so I make 70 rows, put 70 rows in a training data and 30 rows in a testing data. Okay. Mostly researcher can do this, but this is not hard and fast rule to you also do this. According to your data set, you can change the proportion, but mostly persons are taking 70-30 ratio for making the training and the testing data set. Okay. Now, I want to do one classification algorithm to do the classification. Okay. And I already told in the yesterday lecture that this is a classification is a one technique that we can use in a data mining. So I take a one algorithm that name is a random forest. Okay, random forest algorithm. Scrapping is possible. I already conduct a one webinar to scrap the data using Python. Okay, so means it is possible, but this is a means totally a different topic that is not possible to cover in the this particular workshop, because this workshop is just for the data mining techniques, and scrapping is a one type of harvesting the data. Okay, in that is the information harvesting. So, if possible, then we can cover this in a next series of the workshop. Okay, so we can scrap. Okay, but that is not possible to cover in this particular workshop. Okay, sorry. So, first of all, we can take data in a three ways. First, I can build my data set by myself. Okay, so this is primary data. The second way is I can use any CSV file that is already available, means I can use the secondary data. The third is there are various inbuilt data set available in the R. Okay, so if we use that data set, it means that I already use the secondary data set. So there is a one data set that name is IRIS. Okay, that is mostly used in the academics to explain the concept. Okay, so IRIS is a one data set having 5 rows and 150 columns. Okay, so for example, if I run this IRIS, you get this. I run only one line. Okay, you get this. So there are 5 columns. Name are sepal length, sepal width, petal length, petal width, and species. This is the data set to categorize or to classify the flower on the basis of their sepal length, sepal width, petal length, and petal. Understand data set? This is the flower data set to classify the flower species on the basis of their sepal length, sepal width, petal length, and petal width. Means we consider these 4 columns as an independent column and this last column as a dependent column. Okay. In classification, it is compulsory that you must have a dependent column. I already told yesterday that what is classification? Classification is basically example of the supervised learning algorithm. In supervised learning algorithm, it is compulsory that the outcome parameter must be predefined. And what is outcome? That is a dependent variable that must have to available in the data set. If this outcome variable is not available in the data set, you cannot use the classification algorithm. In that case, you have to use the unsupervised learning algorithm that is called as a clustering. Okay. So if labels are defined, you use classification. If labels are not defined, you use clustering. Okay. So IRIS data has the label, so we can apply the classification on the IRIS data set. Now, if you see the data set, that all independent column has the some integer values, decimal values, but the dependent column has the character values. Okay. So we can apply the classification on the iris data. Now, if you want to divide your data into training and testing part, I told you one method. That method name is a sample method. Okay. But in the sample method, if you see that what is my program? In this method, you can see that I have to pass the maximum size and I have to pass the size I want to fetch. I don't put here the percentage, but I told you that mostly researchers make 70% data as training, 30% data as testing. But here we cannot pass percentage. So what we can do to pass the percentage? So there is another way to do this, but for that you required one library. That name is CA Tools. Okay, so how means in my system this library is already installed, but what you can do to install the library, if you have to write install dot packages, okay, and in this you have to write CA Tools. You have to do this because in our inbuilt libraries are not installed. So if I run this code, you require a direct internet connection for same. Proxies are not allowed to install. Okay. So if I run this code, so it is going to install the library. It gives warnings and all that. Don't worry for sake. But at last, it gives you that package CA tool successfully unpacked. Okay. So please install this library. As well as you required one more library for doing the classification. That name is a random forest. So I also write here install.packages and I pass here random forest. Okay. And I also run. So it gives that this package is installed successfully. Please first do these two. And after completing, please comment these lines. Because every time when you run this code, you don't want to install. Please do this. I will come in 1 minute, please. Hello. Everyone done this? Libraries are installed. If any problem in installing the library, you can tell me. Hello. Everyone completed this? Installing the library? Okay. Now, after that, installing the library, there is a this portion. You get a one tab package. Okay. And here you search, for example, CA tools, then you can see this is installed. So you have to just tick this to load. Similarly, you want to use the random forest. So you have to click on this random forest. Okay. Now, to split the data into two parts, training and testing, I use here a one method that name is sample.split. This sample.split method is available under this library CA tools. Means if you want to use this method sample.split, compulsory you have to install and load the package CA tools. Okay. Now, in sample.split, you have to pass that which data you want to divide. So you want to divide the iris data. So I write here iris. Okay. Now, you have to divide the data into two parts, training and testing. The training proportion is 70%. The testing proportion is 30%. So I pass here the split ratio, that is 0.7. So in 70% data of the iris, it gives me a true result. And for 30% data of the iris, it gives me a false result. Okay. Now, to divide the data, I use here one method, that is subset. Okay. Now, in the subset method, I pass the data. And for the training data, I require 70% data where this variable has the value true. So I pass here split equal to true. For you don't get any confusion, so I write the S in place of the split, because this is also split, so you get confused. So if I change this, then I also have to change here. Okay. So 70% data where S holds true, I put in the train part. 30% data where S having the false, I put in the testing part. Okay. Now I can print train as well as I can also print test. So first of all, I print the train. So you get this number of row 3, 4, 5, 8, 9, 10, 13, any random number. It might be possible you get a different number of rows. Are your results are different? Okay, if your result is different and you want that we all have the same result, then what we can do? We can put seed. Okay, so I pass here seed 10 for example. And after that, if I run, mostly we both get the same number of rows. 2, 3, 5, 7, 8. Are you getting the same number of rows? Two, 3, 5, 7, 8. Okay, everyone done this? These lines of code? Okay. Now, to build a model, I required a independent column, then the dependent column, and I also want to put that how many number of trees you want to construct. Okay. So I use here one method, that is a random forest method. So what is random forest? Random forest is a classification algorithm that is used to classify data into labels. Okay. So I have to pass three things in the random forest method. First is the X. So in X, I have to pass the training data. Okay. So in my training data, I already told you that there are 4 independent column and 1 dependent column. Okay. So X is considered as the independent and Y is considered as the dependent. Okay. So in X, I pass here train -5. So what do you mean by -5? It means that this last column is not included in X. Means it independent. In Y, I required only 1 column. So I write train _ species. Now the question is, why I only use train, not test? The answer is, for building any model, we required only training data, not testing data. Testing data we can use in the prediction. Testing data we can use in basically finding the accuracy. Okay. And also, I have to pass the number of tree. You can pass any number of tree here, any integer one. Okay. Now, if I run this code, so you can see that I get a random forest model where it shows that the number of trees are 500. Number of trees are 500. In every level of the tree, there are 2 splits. In the model, there are 3.33% of the error rate. And we classify data into three parts: Sentosa, Versicolor, and Virginica. That is already available in my data set. And number of data that covered in a particular classes. In that classes, you can see that Versicolor has 30 data, but only 29 data is classified Versicolor by the model. 1 data is not classified. So there is some error. In Virginica, there is also 30 data, but only 28 data is considered as Virginica. So there are 2 data that wrongly classify the model. So this is the error. Every model has some error. but we can reduce the error according to our need. Okay. Now, I want to predict that the data set classified by the model and the data set originally available with me are same or not. So for that, I use here one method predict, and for prediction, I require the testing data. So first of all, I have to pass my model, and then I have to pass my testing data. In testing data, I also have to remove the dependent column, because I want to predict the dependent column on the basis of the independent column only. So we don't want to include the dependent column here. Now, if I print this, you can see that this is the prediction. So row number 1 is predicted as Sentosa. Row number 4 is predicted as Sentosa. 6 is predicted. This 66 is predicted as versicolor. Means which row is predicted in which category by the model. That result is shown here. Okay. Now, to check the accuracy of the any model, we require a confusion matrix. So what is confusion matrix? Confusion matrix is a one matrix having the 4 different values that are true positive, true negative, false positive, and false negative. So these are the values we have to put in a confusion matrix. But how we get these values? So we get these values with the help of the testing data and with the help of the value predicted by the model. Means the original values already in the testing data of the label and the value predicted by the model. So you can see here, I use one method that name is table. So table is a method to build a confusion matrix. And confusion matrix is based on 2 things. One is original result. So our original result is in the test variable. I put only the 5th column here because I have to compare the output. Output derived by the model, output originally available. So this is original available output. This is output derived by the model. Okay. Now, if I run this code, you can see I get a 3 by 3 table. So why I get 3 by 3? And in every data set, can I get 3 by 3? No. It depends how many labels available in your original data. In my original data iris, in the 5th column, there is only 3 categories or 3 labels. For that reason, I get only 3 by 3 table. Okay. So if, for example, I have any data set having only 2 things, that is true, false, or yes, no. So what size of matrix I get? I get a 2 by 2 matrix. Okay. Now, if I want to plot that model, so I can use this method, that is a plot, and I pass the model. This is my model. Okay. So if I plot this, you can see this. this type of graph I can get. So in our data set, there are 500 number of trees, and in the y-axis, I get the error. Means, what are the errors when we are building a tree? So you can see that we get errors mostly when our tree size is near about the 60, 70 or 80. After that, the error rate is stagnant. They are not fluctuate. Okay. So in that case, we can decide that we have to build only the trees having the less number of error rate. Okay. So for example, you can see that the error rate is fluctuating here, means it increases. So that number of trees, the size of number of trees, we cannot use in the future because it might be possible we get the more errors. Okay. Now, there is a one plot that is called as importance plot. Okay. So you all know that in our data set iris, we have 4 independent columns, but 1 dependent column. Every column that has the independent characteristics have different importance to predict the outcome. So which column, independent column, has the more importance in your data set prediction? For that, I can use this variable importance plot. It gives you that which particular variable or the column of the data set has the more importance in the prediction. So if I run this, you can get this type of graph. So you can, in this graph, you can see that, 1 minute. You can see that there are 4 independent columns. And what is a Gini index? Gini index is represents you the error rate. So it gives you that as your mean of the Gini index decreases. In that case, you the petal width has the more importance. After that, the petal length has the importance. After that, the sepal length has the importance, and at last, the sepal width has the importance. Means there are 4 columns, but all columns not have the same privileges or the same importance to draw the conclusion or to draw the result. So variable importance is a plot we can use to check which independent column has the more importance rather than the different. For example, there is also a one importance plot. So if I run this, you can see this. These are the numerical values, and we can plot these numerical values here. So means petal dot length width has the highest minimum decrease Gini value. So it has the more importance as compared to the other 3 independent columns. Okay. Then means how means where we can use this algorithm. So I already discussed you that there are lots of the applications of the data mining where you have to classify the data or classify the web pages according to the some independent characteristics. In that case, you apply the random forest algorithm to classify the web pages, to classify the campaign for a targeted user, etc. Hello. Yes, done everyone? Hello. Okay. Now, this is the inbuilt data set. What we can do, if you want to apply this random forest algorithm in the real life CSV file. For example, I downloaded this file chip data set. Okay. So can we apply the random forest algorithm on the chip data set? Yes, we can do this. Okay. So for that, what we have to do? So for example, I take this data. Okay. Now, I have to decide that which column I want to use in the random forest. Okay, so I have this data set, but you can see that last three columns have only the null values. Okay, and some have the character values. So character values we cannot use in the random forest. We require only integer data set. Okay. So for example, there is a process size TDP. These are the columns that we can use in our random forest algorithm. So for that, the columns we require, we can make another data frame. So I write it data dot frame, and I pass here the columns I require. So I take, for example, this is a process size, comma, for example, this TDP. Now I can take one column like vendor. So I have to predict on the basis of the process size and TDP that which vendor is this. Okay. So I write here vendor. So I take only three columns. Now if I print new data, you can see that I get only three columns. Okay. These are only three columns. Okay. But you can see that the name of the column is changed. Now the name of the column is chip underscore data dot process size. Okay. Now what I have to do? I have to use these libraries. Okay. I can copy this code. Now how to do changes? In sample data, what I have to pass in place of iris, I have to pass my new data. Okay. Now here also I have to pass my data. Okay. Now in the training data, the third column is my dependent column. So I have to remove this third column. And I have to pass here train dollar. 1 minute, I have to run this first. Vendor. Okay. And for example, I want to make a 100 number of. I have to also pass here third column. Next, I have to pass here third column, and the rest of the program is same. Okay, so if I run this, there are some null values in the data. So I write here na dot exclude and here. Shows that there are some null values. Are you getting some noise? Hello? Okay, okay, okay. There is some cultural activities are going in societies. That's why I was asking. Okay, okay. shows that there is some null value. For example, I take another column. In the data sets, there are null values. That's why so everyone, please take this column. Okay. Hello. So I take this change in the data frame. So I take three columns. One is a process size, the second is a TDP, and third is a die size. Okay. Now, in this case, I pass here to the two columns doing the plus operation. Okay. You can also write here that I already write in a previous program, that is a -3. Okay. So if I want to print this train -3, for example, So what is gives you the output? So it gives you only the two columns, you can see. Okay. The third column is removed. That we want. Okay. Because the third column we considered as a dependent column. Okay. So we get only these two columns. Okay. Now I pass here in X my independent columns, and in Y I pass dependent column. Okay. Now it depends that how many number of trees you want to build. So you can build a number of tree according to your requirement. Means how many number of trees you want. Okay. So I, for example, consider here only 10, want to build an only 10 tree for classification. We can do only 10. It depends on your requirement, means how many number of trees you want to construct. Okay. So if I run this code, it simply tells that there are nulls in my data set. Okay, so the problem is that in my data set, the two columns, for example, if I run this code, these last three columns having the full null value. So we have to drop this column. Okay, for example, you can see this here also the null values. In this column also the null value. In die size there is a null value. So if there is a null value, then what we can do? We have to replace that null value. So we already done that how to replace the null value. So I can take this code from here, and before using the data set, I want to replace the null value. So I put here this, my data name is new data, and my column name is the last column having the null values. So I die size. Okay. So I have to pass this here. Okay. So in this way, I can replace the NA values. Okay. So if I run this code, then in my data set, the null values in the column die size are replaced by the mean of the die size. Okay. Now, if I divide, so I divide here the data set. So I think there is a more null values in the data. So I can do this step for all my columns. Okay. So I just do this, because in the real life data, the problem is that there are lots of the data are dirty data. So we have to clean the data set. So I take this column process, and here I take column chip data, EDP. Okay. And I just copy the whole thing here and pass here. Also here. Now I take this PDP. Okay. Okay. Now you can see that tree is built. Okay. So the problem we are facing is that there are lots of the null values in the columns. That's why we are not able to build a classification tree. And that problem is mostly with every data set that we have in the real life. That data set is not very clean. In that case, we have to first clean the data. So what we do here, we pre-process the data. And after pre-processing, I divide the data into two parts. That is the training and testing part. Okay. And then build a classification tree. Now, we can plot also the classifier tree. You can see. This is my classifier tree. I have only 10 number of trees. So the values, x-axis values are 2 to 10, 1 to 10, 0 to 10. And these are the errors. There are lots of the errors in the data set. So because we are using the columns according to our choice, we have to take the columns according to the business perspective. Means what business problem you want to solve. According to that, you have to take the columns. Okay. Now, so there are lots of the impurity in the data set. You can see that. Okay. And this is my variable importance plot. Understand everyone? How we can do random forest, apply a random forest in a real life data? So the problem is that means you have to first pre-process your data, look on your data set, which columns you want to use, and is all the column you are going to use are clean or not. If the columns are not ready to use, then you have to make the columns ready to use. And after that, you can apply any classification or any data mining algorithm. Okay. Now, what we can do if there are columns having the character value, but you want to use that value to build a classification model. Value is character. You require a integer value only. Then what you can do? Is there is any way to convert the integer data, convert the character data into an integer? Yes, there is a one method that is called as data encoding, or we can say data factoring. Okay, so in that way we can factor the data. So I tell you how to do this. Okay, So for example, I have one data. I take this my data equal to and I, for example, take one column that is a roll number, for example. I take 3 roll numbers. Then I take a one column name that is, for example, gender equal to, and I pass here male, then comma female, and another is also a male. Okay. Now, if I print this data frame, you can see I get this. Now, I want to use this gender column, but the problem is that gender column has the character one. So, I want to convert this character into a number. So, for example, I want to give iris is not a file, iris is an inbuilt data. So you have to just write the iris. Okay. Now, if I want to convert, then I want to convert which column? Gender column. So I write my data dollar gender equal to 1 minute, please. Hello. So if I want to convert this column, so I have to use the method factor. 1 minute. Okay. Then in factor, I have to first pass my column. So I write my data dollar gender. Then I have to pass the labels. So I pass labels equal to, then I have to make vector. Then I have to pass male, comma, female. Now, I have to define the labels. What labels I want to give? Equal to, for example, I put 1, comma 2. I give male 1 and female 2. Now, if I print my data, what I get? You can see that this gender is converted into 1 and 2. Understand, everyone? Hello? Hello? Okay. So if you want to use any column that have the character values, you can convert that character into a integer using this factor value. Okay, so this is also a part of the data pre-processing to encode the data in a different format. Okay. So this is all about the today's session. Sir?
Yes, ma'am, yes.
Yes.
Yeah.
So in the next lecture, I cover the different classification algorithm like decision tree, naive Bayes, and some clustering algorithm like k-mean clustering and hierarchical clustering.
Okay, okay, ma'am. That will be on tomorrow.
Yes, yes, yes.
7 to 9. We can cover it in 2 hours.
Yes, yes.
Yeah,
We
thank
can cover.
Yeah.
Yeah.
Yeah, thank you. Thank you, everyone. Thank you, ma'am. And see you tomorrow and good night.
Yes, yes. Thank you, sir. Yes. Thank you, everyone.